Alright, this is the robotic arm. Right now it's just kind of waiting. I'm going to show a few different routines I have. This will be the sweep routine. This design kind of show the extent of the available workspace. And this uses a set of routines that uses the angles. So I've done a conversion from the servo settings to the angular settings to control this. So it tries to perform maximum reach. And then it goes for maximum height. And then it'll rotate to the other side. And you can see there are two servos. This is what I've heard of is called a palletizing robot, where there's a linkage that ensures that the end effector stays level throughout all these movements. And the servos are mounted in the base of the arm, which helps it to keep the center of mass low and the moment of inertia small, so you don't have a lot of rotating or moving mass, and helps the payload of the robot. And now it's completed the full sweep routine. So next, oh, and this is also showing the forward kinematics. So as it hits each endpoint in the workspace, it prints out the X, Y, Z coordinates in millimeters as it's sweeping through. And so we'll go ahead and stop that routine. Oh, and by the way, this is a Raspberry Pi Zero. This is actually just plugged into power right now and is connected over SSH here. So I can kill that. This is just on a totally disconnected laptop. So next I will give an example of we'll, hang on just a second, try the arm control routine that lets me just manually do user input. Oops. All right, so that was a little bit sudden, but you can see the prompt now tells me the angular limits for the arm base. So -40 to 40, and I'm calling the base this part here that rotates. So this is theta 0, basically, that I'm manipulating. So I'll just set it to 0, and we see it does that just fine. Now I'll set it to -40, which is about as far as it can turn to the left. I'll set it to +40, about as far as it can turn to the right. And that is pretty much the robot. We'll send it back to 0, so it looks nice. And that's the robot.